In this lesson, we are going to look at pressure heads and the pressure instruments they serve. In order to understand the function of pressure heads, we first need to define static, dynamic and pitot pressures and identify the flight instruments which use these pressures. So let us start with the definition of static pressure. Static pressure is the pressure felt on an aircraft as a result of being in the Earth's atmosphere. It is present when the aircraft is not moving. Static pressure is felt equally all over the aircraft. If the aircraft now moves forward through the air, the leading surfaces of the aircraft will experience an additional air pressure or impact pressure, and this is known as dynamic pressure. The full dynamic or impact pressure will be experienced when the airflow is brought to rest against the moving aircraft. So we can say, in basic terms, that dynamic pressure is the force the air exerts when brought to a standstill against a moving body. The leading surfaces of the aircraft will therefore be subjected to the combination of static pressure plus dynamic pressure, and this total pressure is known as pitot pressure. The word pitot is named after the French physicist who invented a method of measuring total pressure. We can see, therefore, that to find dynamic pressure we simply have to subtract static pressure from pitot pressure. The basic flight instruments which use static pressure only are the altimeter, shown here, and the vertical speed indicator, or VSI, shown here. Both these instruments are dealt with in detail in their own specific lessons. The basic flight instruments which use both static and pitot pressure are the airspeed indicator, or ASI, shown here, and the Mach meter, shown here. Again, both these instruments are covered in detail in their own specific lessons. Pitot and static pressure inputs are also required for an air data computer, or an ADC. This will be dealt with in detail in the lesson on air data computers. Note that pressure instruments suffer from what is known as instrument error. Instrument error is basically due to mechanical imperfections, but this will be dealt with in the lessons on each instrument. Let us now look at pressure heads. Pressure heads are probes fixed outside the aircraft and which form part of pitot and static pressure sensing systems. Pitot pressure is sensed by a pressure head known as a pitot tube, and we can see here that a pitot tube is simply an open-ended tube which faces forward into the airflow. It must be positioned outside the boundary layer, which is air close to the aircraft, which exhibits properties which could interfere with the accuracy of the pitot measurement. A pitot tube usually consists of a head on a strut or a tube on the nose. It is fixed parallel to the longitudinal axis of the aircraft to ensure that the full dynamic pressure is sensed. The air can either be brought to rest inside the pitot tube against a stagnation wall, which is simply a pressure measuring flat surface, and then transmitted up the pitot pipelines to the user instruments, or it can be passed directly up the pitot pipelines. A static head is a perforated tube with its forward end sealed against the airflow. The perforations along its length allow only static air pressure to enter the static pressure sensing system. It is also fixed parallel to the longitudinal axis of the aircraft to reduce the possibility of dynamic air pressure entering the static air sensing system. The pitot and static heads may be combined into a single pressure head, known as a pitot-static head, which we can see in this example. Here we have the static tube surrounding the pitot tube. The systems are still separate, and each system has its own pressure line leading to its own pressure instruments. A heating element is incorporated to prevent the formation of ice. The heating will affect the density of the air, so this must be suitably calibrated out. Any water entering the system is discharged through drain holes. Some air pressure will escape through the drain holes, but this is also suitably calibrated and allowed for in the design. To summarize then, static pressure is the ambient air pressure experienced by an aircraft because it is in the Earth's atmosphere. Dynamic pressure is the force the air exerts when brought to rest against a moving body. Pitot pressure is the combined or total pressure of dynamic and static pressures. The basic flight instruments which use static pressure are the altimeter and the vertical speed indicator, or VSI. The basic flight instruments which use pitot and static pressure are the airspeed indicator, or ASI, and the Mach meter. Pressure heads form part of separate pitot and static pressure sensing systems. The separate pressure heads may be combined into a single pitot static head. A heating element will be incorporated into a pressure head to prevent the formation of ice.